to design our own custom printed circuit boards and ready to send the plans out to be designed and to be fabricated. And now, to talk to us more about the modules, here's Brandon Thomas with the IR Blaster, starting with a demonstration.
Do you find yourself struggling to keep up with your remotes?
Hi, Andrew the Wolfman Wolf here today to show you something really special. It's called the Uniblaster, an IR blaster made exclusively for Google's R smartphone. Have you ever turned on a TV? Have you ever turned off a TV? Have you ever seen a TV? Do you know what a TV is? If you answered yes to any of these questions, the Uniblaster is the thing for you. What's this look like to you? A piece of gum? Well, guess what? You're not even close. It's an IR blaster. What you see right here is just a prototype. How do we fit all that in here? I have virtually no idea, but we did it. Let's hear from an actual test subject.
So, Juan, tell me about the Uniblaster.
This Uniblaster? Oh god, this one says my job. So, I was...
Let me show you how it works. Want to turn on the TV? Just press the power button. Want to adjust the volume? Just one click of the button, the volume's changed. Want to keep changing the volume? Keep clicking the button. Hey, guess what? There's more. The Uniblaster works with every electronic device imaginable. DVD players, Blu-ray, VHS, Laserdisc, floppy disk. Working on a DIY project? Now you can control your time machine from the comfort of your sofa. Do you find yourself struggling to keep up with the Kardashians? The Uniblaster compatible app puts all the controls you need at your fingertips. The price of the Uniblaster has yet to be determined. But I'll tell you what, you send us a blank check and we'll fill in the price for you. No hassle, no mess, guaranteed. Knock down while supplies last.
All right. I'd like to thank Andrew again for channeling his inner Billy Mays and helping us introduce the IR Blaster module. That was obviously a lighthearted attempt for us to get you at least half excited about our summer project as we are. First, I want to start off explaining briefly what an IR Blaster is. IR Blaster is basically a loose term used to describe a device that contains both the infrared LED as well as an infrared receiver. Having both these components in one device allows you to both record infrared signals as well as transmit those back, which gives you control of anything that uses an infrared remote. With all of the ideas you've seen presented, we struggled to kind of come up with a consensus on what we wanted to actually pursue. And the main reason really we chose the IR Blaster was with mainly mechanical and computer science engineers. We figured we'd start with something simple. We wanted something we could see through from start to end and have completed by the end of the summer. And also we felt the IR Blaster with its many uses was a very marketable product. Now I want to take you through a few of the major steps we took through this summer. The first of these was building a proof of concept. As we said, we wanted to start simple, so we included only a single LED and used a Raspberry Pi interface to control this proof of concept circuit. After we had this proof of concept built, we then used the Meta tools, which were so graciously provided by the Meta guys, and we modeled the proof of concept here, and then as time went on, we ended up with our final prototype 2.0 model by the end of the summer. Using these tools allowed us to cut out many of the prototyping tests as well as a lot of time-consuming testing stages. Here we can see two of our ladder prototypes, the first of which has 3 LEDs included to increase the range, but that is still controlled by the Raspberry Pi interface. And the final 2.0 prototype includes not only a microcontroller to improve the timing of the transmission, but also a acrylite shield, which blocks out visible light noise and also improves transmission. Now we kind of just ran through this quickly, so we have another video to show you with some of the more technical details of our project.
Every day, our world becomes more dependent on the electronic devices that surround us. With nearly 1 billion smartphones sold in the last year alone, it only makes sense to integrate these phones with the technological world around us, harnessing the full potential of the one device that never leaves our side. This was exactly our goal in developing the IR Blaster module for Google's Aura smartphone.
The IR Blaster module has been designed to allow the user to emulate any infrared remote on their smartphone. Access to existing databases enables users to download the protocols of nearly all devices on the market. If your device happens to not have an existing file, you can easily record all commands by utilizing the built-in infrared receiver. The IR Blaster puts control of all your devices in one convenient location.
Luckily for us, infrared remote technology has been around for years. However, our main challenges of developing this module were meeting the form factor requirements as well as ensuring its compatibility with the R interface, both of which were laid out in the NDK.
To help us meet these requirements, we utilized the Metamorph software tools to accurately model and test our module. The Meta tools enabled us to cut down not only on the cost of expensive prototype testing, but also the time involved in the design process. By allowing us to rule out infeasible design choices, we were able to optimize our circuit to fit in the specified module dimensions and achieve the greatest performance, all from a single interface. At this time, our module is operated by keyboard inputs through an Arduino microcontroller. Commands are executed by simply pressing a designated key. Our software team has been diligently working to allow our module to be controlled from an Android app interface, and we plan on this being achieved by the conclusion of the summer.
Although there is some software development yet to be done, we are pleased to announce that our hardware design is complete and ready for production. We have a finalized 3D CAD model of the IR Blaster module, as well as a fully designed printed circuit board. We were hoping to have the final hardware prototype to present today. Unfortunately, we did not receive the circuit board in time to assemble the components and show its functionality.
As a team, we are honored to have had the opportunity to work on Project Aura.
It has been a gratifying experience working towards the completion of our ultimate goal.
The development of a fully realized module ready to be manufactured.
Alright, so that was our IR Blaster. Our next module we're going to present to you is our glucometer. Nate's going to come up and talk to us about that, but first we have another video to introduce it to you.
Walking down the street as I check the time. Gotta get my glucose levels in case I'm gonna die. Reach in my pocket, find my phone, wallet, keys. Reach a little deeper, then I start to freeze. Mama left my glucose meter back at the pad. I really need it now if things could get bad.
I heard you there's a glucometer back at home. Don't fret, take a breath, I got one here on my phone.
On your phone?
On my Aura phone. So let me see your finger and get a quick. In no time at all, you know if you're sick. Click, save, your dad is backed up. You send it to your mom, your doc, or your pop.
Man, this is cool, where can I get one? A glucometer on the phone, that must cost a ton.
No, not really, that idea is whack. The starter kit will only cost you $50 flat. Then from there, you just pick and choose what you want on your phone. It's up to you.
What a way to get things started. My name is Nate Bremer, and I will be talking to you today about the glucometer module. For those of you who are not aware, a glucometer is a medical device used to determine the concentration of glucose in the blood. Glucometers use an enzyme-coated test strip that produces a measurable current that is proportional to the amount of glucose present in the blood sample. Today, about 38 million people are affected by the disease, with 5% of those people having to test themselves multiple times a day. Furthermore, about $550 billion is being spent per year on healthcare. There are many benefits of a glucometer module, including its conveniently embedded design. With this module, the data from each test can be collected over time and analyzed by the user or a medical professional. This data, along with data collected from multiple other modules, can be used together to help fight the disease. Because of our internship, we were exposed to the meta tools, a collection of analysis tools that expedited our design process by lessening the number of prototypes. Through the use of the meta tools, we were able to find the final output voltage of the entire circuit, measure certain electrical values within our circuit, and determine whether our components would all fit onto the printed circuit board. Our first proof of concept prototype on the left involved the use of 2 op amps to lower the voltage and to convert the test strip's current into a readable voltage. By treating the test strip as a variable resistor, we were able to measure different output voltages as a result of changing that resistance value. Because the op amps we chose for our first prototype didn't fit the form factor of the module, we had to search around for smaller sized components. Fortunately, we were able to find a microcontroller that had all the circuit components as well as an analog to digital converter with the capability of communicating with the endo. For these reasons and its better reliability, we chose to use this microcontroller in our final prototype.